Alright, welcome back. I'll first like to give credit to the authors of these items. This material is from Jam Remix. Alright, let's tackle theoretical questions here. These chapters would cover Newton's law of motion, law of conservation of momentum. So let's get straight into it. 1. Skip. The skip questions, I'm going to solve those questions separately in a separate video. 2. A man stands on a spring balance. Do not forget, spring balance, I said in the first chapter, spring balance measures weight, while beam balance measures mass. Meaning, also, I said gravity affects spring balance, but gravity has no effect on beam balance. And lastly, spring balance works on the principle of Hooke's law, while beam balance works on the principle of moment. Do not forget. So next, a man stands on a spring scale. Placed in a lift, the lift descends at constant velocity. As a result, the scale reads, what would the scale read? There's a little bit of complex derivations to this, but what the scale will read is the same as the weight of the man. Next question is skip. Next, skip. 5, skip. 6, skip. There are not too many calculations, theories here, sorry. 7. Which of the following is a correct explanation of inertia of a body? Which of the following is a correct explanation of the inertia of a body? Inertia, right guys, inertia means reluctance to start moving and reluctance to stop moving. So 7 is option E. Reluctance to start moving and reluctance to stop moving once it has begun to move. 7 is option E. 8. Which of the following is not a force? Impulse is not a force. Yes, impulse is not a force. But, right, impulse is not a force, but impulse is the product of force and time. So, impulse is not a force. 9, skip. 11, skip. 13, skip. 14, skip. 15. I would like to give this one. A particle of mass m, which is at rest, splits up into two if the mass and velocity of one of the particles are m and v respectively. Calculate the velocity of the second particle. This one you need to know the formula. So I will just go straight to tell you is option D. mv over uppercase m minus lowercase m. So 15 is option D. 16, skip. 17, skip. 18, 19, skip. 20, skip. Okay. 21, skip. 22, skip. 23, skip. 24. In an experiment, a constant force is applied to several masses and the corresponding accelerations are measured. Which of the following graph correctly represents the experiment? Which of them would correctly represent our experiment? Since we are talking about force and mass times acceleration, 24 would be option A. This graph and this graph. III and IV. They represent force. These two graphs, they are the graphs of force. Look at them very well. If I were you, I would take them down. A here, acceleration here. You could write it in full in your note. Acceleration here, 1 over mass. You could see. Here's the graph. Next, so the slope is upwards. See, the slope is like this. You have like the C slope, you're having acceleration and also you have mass. So put them together. The both graph are the graph of force. I think we might come across another question similar to this. Keep the both in mind. 25, skip. 26, skip. 27, skip. 28, skip. 29. If the total force acting on a particle is 0, The linear momentum would do what? Force is not acting on something. What would happen to its linear momentum? Would be constant. Option B. 29 is option B. 30 skip. 31 skip. The question actually stopped at question 40. 32. Jet propelled aircraft, rocket propulsion, the recoil of a gun, a person walking. Which of the above is based on Newton's third law? Do not forget Newton's third law is the law of action, is the law of action and reaction are equal and opposite. Okay, so 32 is option A. Jet propelled aircraft, rocket propulsion, recoil velocity, and person walking. 32 is option A. 33 out of it. Okay, 34. Okay, a man standing on a lift that is descending does not feel, supposed to be feel, not feel, does not feel any weight because there is no reaction from the floor of the lift. Option A. 35 skip. 6 skip. 7. When an X-ray collides elastically with a free electron, there is conservation of 37. There will be conservation of both momentum and energy. Option B. The last question is question 40. 38. The tendency of a body to remain at rest when a force is applied to it is called. 38 is option C, inertia. 39 skip. 40 skip. And those are the questions we have on this chapter. If you've gotten to this point, well done. I gave a few points, not too many. Hopefully you jotted them down. I'd like you to do something for me. Snap it and send to our WhatsApp group for assessment. And please do note, if this is your first time coming across this video, do well to subscribe and also leave a like. And you could also share with your friends. And also be reminded, or I'd like to let you know that we run a private mentorship smart class. If you'd like to join our smart class, I'm going to leave the link to the WhatsApp group in the description box. Thanks for watching, and I'll see you in the next video. If you have a question, you could leave your questions in the comment section, or you send your question directly to us on WhatsApp. See you in the next video. I'm Coach Ewing.